compute the volume for the following problems using the shell method. Here, for exercise 1 to 14, they're all revolving about the y-axis. So for number 3, they have the graph for us, and you see the rectangular slice, or the radius, or here in this case h for the height. The thickness is dx. So this is h of x for the height. That's the square root of x. And then the distance from the axis of revolution to the center of the radius is p. Here this is p of x, and p of x is equal to x. So the volume, based on the shell method, is 2 pi times the integral. Now with respect to the x-axis, the values of this volume would go from 0 to 4 for the interval of integration, that is. And there we have p of x times h of x, which is x times the square root of x dx. This is 2 pi times the integral from 0 to 4 of x to the 3/2 power. We do not hesitate, we integrate. So this is x to the 5/2 all over 5/2. And this is being evaluated from 0 to 4. And so the volume is 2 times 2 is 4 pi over 5 times x to the 5/2. That's evaluated from 0 to 4. And so this gives us 4 pi over 5 times 4, which is 2 to the second. That's raised to the 5/2 power. And that's minus, you evaluate this term at 0, so you get 0. So we get the volume. Now that's 2 to the second raised to the 5/2. It's just 2 to the 5th power. So we get 4 pi over 5, and this is 2 to the 5th, or 32. And so we get 128 pi all over 5. Okay. Well, what about the next problem? It's number, I think I have it here, number 3. A lot of wasted space. That's better. So here, y equal to x squared, y equal to 4x minus x squared. And this is about the y-axis. We need to graph these two. I think we've seen them before in the previous section. So this is the parabola going upward. This is the parabola going downward. And for this one, it has x-intercepts at 0 and 4. Let's see if we can graph this. We have that parabola going upward, then the parabola is going downward. Remember, this was the one that gave us the moon. And this is being rotated about the y-axis. So if we come over here and see if we can kind of highlight what we want. If we take a rectangular slice, remember that the radius is parallel to the axis of revolution. This is our height. Then you want to calculate the distance from the axis of revolution to the center of the radius. So that will give us what we call P. And this is P of x. This is H of x. So since the axis itself is given, here the axis of revolution is the y-axis, and the thickness of the radius is with respect to x. So P of x is equal to x. Now the height is the function, basically the area, the function up top minus the function below. The function that's up top is this parabola that's facing downward. So h of x is 4x minus x squared minus the bottom function, which is x squared. Remember, there was a problem in the previous section that I started to put the height there, and then I realized that I was doing the disk method and not the shell method. Well, now I can do what I wanted to do back then. I guess I need to make this H blue. Okay. So the height is 4x minus 2x squared. And so the volume, I think we're ready. Well, we need to know, and I don't remember from the previous section, we were integrating with respect to x from 0. I think it was 2, but let's just verify. So we just set the equations equal to find the points of intersection. Yeah, it was 0 and 2. If you remember that, you can just go ahead and go to it. This is 2x squared. I got too much stuff going on. Two x squared minus 4x. Set that equal to 0. Get 2x times x minus 2 equal to 0. This implies x equal to 0, x equal to 2, or our points of intersection. So that simply tells us that we are evaluating from 0 to 2. So the volume is 2 pi times the integral from 0 to 2 of P of x, and P of x is x, times h of x, and h of x is 4x minus 2x squared. Dx. This is 2 pi times integral from 0 to 2. This is 4x squared minus 2x to the third dx. So now we can integrate. So we get 4x to the third over 3 minus 2x to the fourth divided by 4. So that's just x to the fourth over 2. We evaluate that from 0 to 2. So the volume is 2 pi times here 4 times 3 over 3 minus 16 divided by 2. It's just 8. So we get 2 pi this is 2 raised to the third is an 8. I was about to say we cannot have a negative volume. Could you remember? So this is 4 times 8. That's better. So this is 32 over 3 minus 24 over 3. So we get 16. Right, it's 8 times the 2 pi. So 16 pi all over 3. Okay. That's number 7. Let's look at number 9. Is it doing that? Oh, excuse me. It's Dr. Pepper time. Whew, I tell you. Good stuff, right? It's probably not good for you, but it will keep you up. How about that? So let's look at this guy. So we have y equal to 4x minus x squared, x equal to 0, y equal to 4 about the y-axis. Let's see. Trying to do my rotation. Let's do it in red. All right, now. So we've seen this graph before. This is the upside down parabola with x-intercepts at 0 and 4. And then it says x equal to 0. X equal to 0. Right? So that's this guy right here. And then y equal to 4. Let's see. Let's set these two equations equal to make sure we find out exactly where that is, where the line y equal 4 is in reference to this. So if we set y equal to 4, so we have 4 is equal to 4x minus x squared. And so that gives us x squared minus 4x plus 4 equal to 0. So x minus 2 to be squared is equal to 0. That gives us x is equal to 2. So that's right there at the tip top. So 2. And this is 4. So the volume is right here. So we're calculating this volume. And this guy that you're actually calculating is that piece, right? So at any rate, The axis of revolution is the y-axis, and so we need to go over here, come over here and draw it so we can kind of see what we need. That's what we're looking at. So if we're revolving about the y-axis, then the radius is parallel to it. So this height, so-called height of this this solid, this is dx, so it's h of x. The height is this line here, which was 4, minus the curve. The curve is given by this 4x minus x squared, so it says minus 4x plus x squared, right? Because we're minusing that. And the distance from the center of the rectangle to the axis of revolution is p. P of x is equal to x. So now the volume can be found. This is 2 pi times the integral of p of x times h of x. This is x times 4 minus 4x plus x squared dx. And since we're integrating with respect to x, x is going from 0 to 2. So we have 2 pi times the integral from 0 to 2. Simplify this. This is 4x minus 4x squared plus x to the third dx. So here the volume is 2 pi. We integrate now. So we get 4x squared divided by 2. So that's 2x squared minus 4x to the third all over 3 plus x to the fourth all over 4. Let's evaluate it from 0 to 2. So we plug in x to be 2. So we have 2 pi. So here we get 4 and 2. So that's 8 minus 4 times 8, 32 all over 3 plus 2 to the fourth, 16 divided by 4 is 4. And so this gives us 2 pi, and inside the parentheses is 12 minus 32 over 3. So we get 36 minus 32 is 4 times the 2 is 8 pi all over 3 for that volume. Okay. Now, number 25, and I believe this is the last one that I will work. Let's see. Oops. So we have y equal to x squared, y equal to 4x minus x squared, which seems to be a repeating type problem. It's repeating, and for the author's sake, but also for my sake, because I keep on picking it as well. Just want you to see the various ways we can manipulate similar problem, and it's interesting. And in mathematical science, researchers would spend years just dealing with one problem, very difficult problem, but that's the only problem that they deal with. And looking at the various the variations of that particular problem. So here we are revolving this about the line x equal to 4. So this is not the x-axis revolution or the y-axis revolution. So if that be the case, then we said from the instructions that p of x would equal to 4 minus x. Okay. Try to see that with the graph. You remember this graph was the moon. You had the parabola that was underneath, and then you had the parabola that was above, and it was curving down, and it gave us this moon piece right there. Right? And so where the two intersect to find this point here, we set the two equations equal. It seems like we'll keep doing it over and over again. This point here is 2. Problem we've kind of seen for a million times, right? 4x minus x squared is equal to x squared. So that implies that 2x squared minus 4x equal to 0. So we get x equals 0, x equal to 2. Points of intersection. So this, I did that to make sure that this point is there, and this line x equal to 4 is way over there. So if this was the disk method, you know, we use that washer to kind of pull out the hole. That's going to work for us with when you solve for p of x. The radius is parallel to the axis of revolution, has a thickness of dx. Right. This guy right here is the height, h of x. H of x is the function above minus the function below. So h of x, the function above, is the 4x minus x squared, and the function below is the x squared minus x squared. So this is 4x minus 2x squared. P of x goes from x, well 4 that is, all the way over here to the center of the radius, and that change to shrink it is moving with respect to x. So you have here 4 minus x. That takes into consideration the whole, this empty space. You don't want to calculate that. So the neat thing about the shell method is that it takes the washer piece into consideration automatically. So here this is 2 pi times the integral from 0 to 2. P of x is 4 minus x, and h of x is 4x minus 2x squared. This is dx. So this is 2 pi times the integral from 0 to 2. We simplify this, so we have 16x minus 8x squared minus 4x squared plus 2x to the third dx. So the volume is 2 pi. I think we can simplify that just a little bit more. This is 16x minus 12x squared plus 2x to the third dx. So this is 2 pi. Now we integrate. We get 16x squared divided by 2. So that's 8x squared. Evaluating that from 0 to 2. And then we have minus 12x to the third divided by 3. So that's minus 4x to the third plus 2x to the fourth divided by 4 is x to the fourth divided by 2. It's being evaluated from 0 to 2. So the volume is 2 pi. Plug in x equal to 2. So we get 4 times 8, 32, minus 8 times 4, 32, plus 16 divided by 2 is 8. And so our volume is 16 pi. I think that'll do it. Thank you.